Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh, and welcome everyone. This video will be discussing chapter 10. Chapter 10 is talking about aerated lagoons. Aerated lagoons is one of the most or one of the famous methods for wastewater treatment. Okay, let's have an introduction. So first of all, the aerated lagoons, these are considered as suspended growth type. Suspended growth type, because as you know, we have two types of biological treatments, two methods. We have the suspended growth and we have the attached growth. So aerated lagoons are one of the suspended growth types, similar to activated sludge, similar to waste stabilization ponds. Okay. And the idea is almost the same of activated sludge. However, there is no sludge recycling. Okay, no sludge recycling. Then normally in the aerated lagoons, those are very huge ponds and with a very wide area, and normally we use mechanical aerators. Mechanical aerators can be floating aerators. It can be submerged aerators as air diffusers. As you can see in the picture below, this is a schematic diagram of an aerated basin with surface aerators. Okay. In fact, surface aerators or aeration in general in the aerated lagoons provide or play two functions. The first function is to make or to provide the required oxygen, the required air for the biological accumulation, the biological treatment, and also provide the mixing required for the biological or for the bacteria and the organism to contact with the reactants or with the wastewater components, the organic matter. So it provides the oxygen, it provides the mixing required for the treatment process. Okay. BOD removal, it can come up to 90%, which is very efficient. Hydraulic retention time in these ponds is 2 to 6 days. The mixed liquor suspended solids is 200 to 400 only. Okay. Unlike the activated sludge is always like 3,000, 5,000. Okay, because here there is no sludge recycling. And also here there is no settling in the lagoon. If you can remember, in the WSP waste stabilization pond, the ponds there is divided into 3 zones. But here in the suspended growth type, here in the aerated lagoons, all the lagoon is considered as one zone. There is no settling. And this is because of the aeration, because of the mixing and the turbulent mixing in the lagoon that is applied to make the mixing between biological components, the organic content and the biological creatures. Okay, this is a photo of aerated lagoon, and as you can see here, this is the floating surface aerators. Okay, it is always floating on the top, on the surface of the lagoon, and provide mechanical aeration, mechanical mixing. This will mix the water and allow the air to be mixed or to enter and to be dissolved in the water. This is another photo. As you can see, this is a floating surface aerator. Regarding the diffuser, it is same. It can be arranged similar to the activated sludge systems. However, normally in the aerated lagoons, as you can see, it is a very wide area. So normally we use surface floating aerators. Okay. Now let's go to the design equations. First, aerated lagoons, normally it follow the maturation normally they are followed by maturation ponds, just like the waste stabilization pond. Okay, so the main difference between waste stabilization pond and aerated lagoon is in the stabilization ponds. Okay, now in the facultative pond, in WSP we have facultative ponds, we have maturation ponds. In aerated lagoon system we have aeration lagoon or aerated lagoon and then maturation ponds. So what is the main difference between aerated lagoon and facultative ponds? The aerated lagoons, we apply mixing, we apply mechanical aerators. However, on the other hand, in the facultative ponds we don't apply any kind of mixing. Okay, so this is the main difference. Okay, now normally the depth is from 2 to 4 meter. Okay, and the effluent of BOD can be divided into two types of effluents. Okay, now here we have to focus, we have to concentrate on the two kinds of effluents. We have dissolved BOD and we have solid BOD or undissolved. Okay, dissolved organics, solid organics. Okay, why we consider both of them? Because here there is no settling. There is no settling in the aerated lagoons. So the effluent will contain both. Will contain dissolved organics and will contain solid organics, because the suspended solids is not settled in these lagoons. Okay. Now let's move to the relationship between the influent and dissolved. As you can see, we put it in the red color. So this is the dissolved. Okay, so this is Fe. Fe is the effluent or BOD effluent, but for dissolved organics only. Okay, so we are dividing now to dissolved and solid. So the Fe equals Li over 1 plus Kt. Li is the influent BOD5, 1 plus K. K is the dissolved BOD removal rate constant. So this constant is for the dissolved organics only. Okay, so don't mix between them. And T is the hydraulic retention time. Okay, and this is an adjustment. Okay, this is an adjustment for the K according to the temperature. So K20 equals KT equals K20 times 1.035 to the power T minus 20. Okay, now let's move to the BOD effluent, which is the mix between, or the combination between dissolved and non-dissolved, which is the solid, and we will call it Le. Okay, and this can be computed by the equation below. Le, this is the total or the combined effluent. This is the combined effluent which we are looking for at the end. Okay, equals Fe. Fe is the dissolved, okay, is the dissolved effluent plus 0.95 X. So what is X? X is the undissolved or the non-dissolved organics. Okay, as you can see, this is the red color represents the dissolved. The blue color represents the non-dissolved. Okay, so X is the cell concentration in the lagoon, or in other words, it is the suspended solids. Okay, X can be computed, can be calculated by the following equation: Y times Li minus Fe over 1 plus Bt. Okay, so these are the parameters. Y is the yield rate coefficient, equals 0.6 to 0.7. Okay, and B is it is called the autolysis rates, and normally those parameters are obtained from lab test. Okay, from laboratory tests. Okay, now let's see a simple example. Okay, so these are information given for us to design an aerated lagoon system. Okay, and we will see how to design the aerated lagoon including maturation ponds. okay, because the system has or must include the maturation pond. We have Li. This is the influent BOD. Okay, influent BOD is 200. T is 4 days, and temperature is 20 degrees. K1 is 0.3, and K is for the dissolved organics is 5 days, 5 per day. Okay, B and Y are given. Q is the flow, 10,000 meter cubic per day, and LE after the maturation, which is the final combined effluent, is 20 milligram per liter. So let's see how we deal with these numbers one by one. First, the depth, if it's not given, you can assume it from 2 to 4 meters, so we assume it as 2.5. okay, so we have the depth, we have Q, we can calculate the area. Okay, A, the area, equals Q times T over D. This is D is the depth, so 10,000 times 4 days over 2.5. okay, so the area equals 16,000 meter square. Okay, now we can determine the dissolved effluent BOD. This is the first component. This is the first component of the effluents, okay, of the effluent BOD. So Fe equals Li over 1 plus Kt. Li is 200, 1 plus K, K is 5. We have two Ks, we have K and K1. K is for the dissolved effluent, okay. 1 plus 5 times 4. K is for the aerated lagoon, and K1 is for the maturation ponds. Okay, so this is just to not to be confused between K and K1. Okay, so 1 plus 5 times 4. So the Fe equals 9.52. Are we done? No, not yet. We have to continue to calculate the cell concentration in order to have the combined effluent. Okay, so cell concentration X equals Y times Li minus Fe over 1 plus Bt. So Y is 0.65 times 200 minus 9.52, and notice here that we substitute BOD as it is, milligram per liter. Okay, not as before, or not as in the chapter 7 activated sludge system we substitute as kilogram. No, here we substitute as milligram per liter as it is. Okay, 200 milligram per liter minus 9.52 milligram per liter over 1 plus Bt. Okay, so the X equals 96.73. okay, so now we can calculate the lagoon effluent BOD. Le equals Fe plus 0.95x. So the final answer is 101.4. Are we done? Yes, we are done for the lagoon effluent. Okay, because we have two effluents. First effluent is coming out from the lagoon. Then this effluent will be sent to the maturation pond. So let's continue to design the maturation pond and see how this effluent will be converted. Okay, so the raw wastewater was having Li was 200 milligram per liter. It enters the lagoon. Okay, after discharged from the lagoon, the BOD concentration is 101.4. okay, now let's continue to the maturation ponds. Now in the maturation ponds, yes, there will be settling. Okay, because there is no mixing in the maturation ponds. The mixing is only in the aerated lagoons. Okay, the first step. The second step, maturation ponds, there is no mixing, so there will be settling. Okay, here we have to assume something. we have to assume always that there is a portion of the solids that will be settled in the maturation pond, and the other portion will be flowing out of the pond. Okay, so in order to know the Li for the maturation pond and the Le for the maturation pond, we have to calculate the Li based on the available or based on the existed suspended solid, which is not settled. Okay, which is not settled. Okay, one by one. If we assume that 60% of the solids were settled in the maturation ponds, so we can know the Li of the maturation pond. So this Li is for the maturation pond. It is not the same Li as we calculated as it given the 200. No, this is the Li entering the maturation pond. Okay, so equals the Li equals Fe. Okay, from the equation is same as the equation. Fe is calculated before plus 0.95 times x, but x is not all existed as suspended. Only 40%, which is 0.4 of the x, is suspended, and the rest is settled. Okay, so that's why we multiply by 0.4. If you assume 70% of the solid settled, so you multiply by 0.3. If you assume 65, let's say, okay, 65, so the x will be multiplied by 0.35, which is the remaining not settled. Okay, so the Li entering the maturation pond should be 46.5 milligram per liter. Okay, let's continue. So here we can compute the retention time for the maturation pond. Okay, the same equation we used before. This Le equals Li over K1 times T plus 1. Okay, this is the same equation of maturation ponds used in the WSPs. Okay, fine. Now we can calculate T, because we know Li, we know Le, K1 is given, so we can calculate the time T. So the T in the maturation ponds equals 4.42 days, calculated from the equation. Okay, now this is a previous final exam question, which I would like to share with you, and we will solve it together. So an aerated lagoon system is designed to treat sewage from a residential area with a BOD of 150 milligram per liter. So this BOD should be the Li. Okay, the system consists of an aerated lagoon followed by a maturation pond. Both have the same HRT. Okay, now the minimum operating temperature is 25. So here the temperature is 25, is not 20. Wastewater characteristics are given as the Y, the B, the K, and K1. Okay, so take note that K is for the aerated lagoon and K1 is for the maturation ponds. Okay, all values these are at 20 degrees, so we have to convert. Now with the dissolved BOD effluent from the aerated lagoon is 8, calculate the following. Okay, from the aerated lagoon effluent is 8, so we have to calculate the HRT, the total lagoon effluent BOD, and the effluent BOD from maturation pond, assuming that 60% solids removal in the pond. Okay, let's start. First we have to convert the K25, okay, to the K20 we have to convert it to K25. So using this adjustment equation, K25 equals 5.94 per day. Okay, then using the equation Fe equals Li over 1 plus Kt, this is to calculate the dissolved BOD effluent. Okay, so Fe equals 8 is given, okay, after the lagoon. Li is 150, so we can calculate the T. T is the hydraulic retention time. This hydraulic retention time should be the same for the pond and for the maturation pond, for the aerated lagoon and the maturation pond. Okay, so HRT from the equation is 3 days. Okay, now let's see how to calculate the second requirement. First of all, we have to calculate x. X equals y times Li minus Fe over 1 plus Bt. So as you can see in the equation, all parameters are given. Okay, we just substitute and x equals 76.28. Okay, then Le, the effluent or the combined effluent, okay, equals Fe plus 0.95x. Fe is 8 plus 0.95 times 76.28. So the combined effluent, which is dissolved and non-dissolved, equals 80.48 milligram per liter. Okay, and then moving to the third requirement, so we have to calculate the Li of the maturation pond. Okay, I forgot to write and note that this Li is for the maturation pond, but it is known by default. So Li equals 8 plus, okay, this 8 is the effluent of the, or the dissolved effluent of the aerated lagoon. Then we have to add the portion that is not settled in the maturation pond, which is 40%, because 60% is settled, so 40% will be suspended. So 0.95 times x and multiplied by 0.4, which is the 40%. Altogether equals 37. So Li entering the maturation pond is 37. Okay, again, Li of the maturation pond is expressed as the Fe. Fe is the dissolved BOD coming out from the aerated lagoon. So this dissolved BOD coming out from the aerated lagoon, it will enter the maturation pond. Then we have another portion of the BOD, which is the suspended BOD, not dissolved. Okay, so the non-dissolved, but it is suspended, not settled down, because if the settled down is not taken into consideration. So 0.95 times 40% of the x, and altogether is 37. Okay, and then we have to convert K1. K1 same as in the WSP calculations. So K1 conversion or adjustment equation is, as you can see, K1 20 times 1.05, okay, to the power t minus 20. So the new K1 is 0.383. Okay, now finally Le, this is the Le from the maturation pond. So this is the final Le. Okay, Le equals Li over K1t plus 1. So 37 over 0.383 times 3 and plus 1, and altogether is 17.22 milligram per liter. Just right here, milligram per liter. Okay, and that is the end of chapter 10. I hope you enjoy it, and if you have any question, don't hesitate to ask. Assalamu alaikum wa rahmatullahi wa barakatuh.